Hello and welcome to today's tutorial. So today we will continue with the summer with respect to the last tutorial. In the last tutorial we talked about the summer non-inverting, a summer inverting configuration circuit. So in this tutorial we are going to talk about the summer non-inverting configuration. So let us switch back to our screen. So let me clear this and I'll write here. So we are going to discuss on summer in a non-inverting configuration. So in case of the summer or adder in non-inverting configuration, so all the input voltages are connected at the non-inverting terminal and those voltage sources are get added up and that we will get across the output. So let us see the circuit of this. So it is similar to our non-inverting amplifier circuit. Only thing is that the input voltage sources are connected to multiple voltage sources are connected to non-inverting terminal. So you see from this, so we have a resistor R1 here and a feedback resistor RF which is connected to an inverting terminal, that is to V1, and the other voltage source through a resistor RA, RB and RC are connected to a non-inverting terminal, so that you can see from the circuit here. So it is like this. Yes. So let us name this voltage source as VA, VB and VC, and resistors as RA, RB and RC. So at this point we call this as V2 and this is our V0. So then to continue with the analysis of the circuit, so we have to apply a Millman's theorem for this. So if we apply a Millman's theorem, then this part of this circuit, that is nothing but the voltage source which are connected to a non-inverting terminal, so that can be written as like this. Then there is one more resistor here, so that is connected all to these points. So let us call this as point as V2. So as we all know, this is RA, this is RB and this is RC, and this is VA, VB and VC sources. So the Millman's theorem, from the Millman's theorem we can write the voltage across the V2 terminal is equal to the VA by RA plus VB by RB plus VC by RC whole divided by the resistance connected in parallel. So we can write this as RA 1 by RA plus 1 by RB plus 1 by RC. So if we consider a special case where RA is equal to RB is equal to RC, if all these three resistor values are equal, then finally our equation, so let me move this section here. So our equation, that is V2 equation, will come down to, so finally the V2 equation will just become, it is VA plus VB plus VC by, we will get this as 3 because ultimately it is 1 plus 1 plus 1 whole divided by, it is RA plus RB, so we will get 1, so it is, we will get it as 3. So finally this equation is applicable only if all the three resistor values are same. So now from the non-inverting amplifier circuit we know the equation. Let me move out this equation here for time being. So we know that for a non-inverting amplifier, it is just like a non-inverting amplifier case. So the final output V0 is given by the closed loop gain is given as 1 plus Rf by R1, or what we have written, yes, it is in this case it is R1 into Vs. So here Vs is nothing but in this case it is V2. So finally, so if we substitute for the value of V2, then we will get this as 1 plus Rf by R1 into Va plus Vb plus Vc all divided by 3. So this is the equation of an adder of a non-inverting configuration. So you have to remember this equation to apply directly to the examples which will going to work out. Let me repeat again, this equation is applicable or holds good only if the value of Ra, Rb and Rc is same. Otherwise, we have to resubstitute this equation, that is V2, with Va by Ra plus Vb by Rb plus Vc by Rc whole divided by 1 plus Ra plus 1 by Rb plus 1 by Rc. That equation we have to substitute here. So let us look into the example here. So let me clear this screen, or let me save this page. I'll save this page as 33 and take the new page. So let us take an example here where we have to find the output voltage of an op-amp. So the circuit is given like this. So where an op-amp is connected through a 3 resistors. So let us give the values for these resistors and then we can start with analysis. So this R1 resistor is connected to ground, so this is R1 of 1 kilo ohms. Then Rf is equal to 10 kilo ohms. Then all these 3 resistors, that is Ra, Rb and Rc values are same, so it is 1 kilo and this is 1 kilo, and the input voltages are 0.1 volts, this is 0.3 volts, and the other one it is 0.2 volts. So this is V1 point, this is V2 point here, so we have to find the output voltage V0. So we will apply the same formula which we had discussed just now. So in this case we can say that all the 3 resistor values are same, so we can apply the formula, that is V0 is equal to 1 plus Rf by R1 into Va plus Vb plus Vc whole divided by 3. So if you substitute the values here, so now it is 1 plus Rf value is 10 kilo, so 10 kilo by, it is 1 kilo of, it is now Va is 0.1 volts plus 0.3 plus 0.2 whole divided by 3. Simplify this, then finally we're supposed to get the value of 2.2 volts. So likewise you can do any kind of examples. We can also try, you can also try with the cascade examples. So let me give you one assignment so that you can solve it by yourself. Let's take the case, let me clear this. I'll give you the example of a combination of inverting amplifier, non-inverting amplifier and a summer, and again a kind of a amplifier circuit. So it's a kind of and you need not to worry, it's not much complicated, just you have to apply your brain. So I'll be using here, so one circuit, so this is 8 kilo ohms, so here it is 2.2 kilo ohms, 2.2 kilo ohms. So here let us say the voltage is minus 5 volts, then this point is connected to ground here. So this is an inverting terminal, non-inverting terminal here, non-inverting terminal is grounded. So we have one more op-amp circuit here, where we have this feedback circuit, and this is connected here, and this is connected to ground. So this is 1 kilo ohm, and this is 5 kilo ohm, and this is connected to say 10 volts. This is inverting and this is non-inverting terminal. So now we have this connected through a resistor, we have this connected through a resistor, and we have this connected through a resistor to one of the inverting amplifier case, and this is say 6 volts. So this is 2 kilo ohms, this is 3 kilo, this is 5 kilo ohms, and all these points are connected to an op-amp inverting terminal. Then this is connected to a feedback resistor. So here let's take this as 10 kilo ohms. So now here you have to find what is the final output of this circuit. It's very simple. You have to treat this individual circuit, find the output corresponding. So I'll just give you the hint at this point. So this circuit is your this circuit, the first circuit is the inverting amplifier case, this is a non-inverting amplifier, and this is a summer with inverting configuration. So I don't want to continue or make this much more complicated. So yeah, you can solve this. Hope all the parameters are given. If any parameter is missing, then you can assume some of the parameters and you can consider it. Okay, so this is about the summer circuits of inverting and non-inverting configurations. Inverting we have discussed in the previous tutorial. So in this tutorial we have discussed about the non-inverting configuration. So before proceeding to other circuits, I want to discuss one more topic here. So that is another important or a special case, if I talk about, of a non-inverting amplifier is a voltage follower. So let me clear this, or okay, let me save this. It might be useful for me later. So page 34, I'll take new one. So let us talk about a voltage follower circuit. So voltage follower circuit is a special case of non-inverting amplifier where the output voltage is fed back to a inverting input. So let us say this circuit here first. So this is our op-amp, and we are connecting an voltage source to a non-inverting terminal. So here we have taken an example of sinusoidal input. We call this as Vs, and the output is fed back to input. So if you compare this circuit with our inverting amplifier, so let me write the inverting amplifier circuit here so that we can compare it. So this is our inverting amplifier circuit. This is our R1, this is RF where, this is our RF where the RF is a resistor which feedbacks our output voltage back to the input. So now if you look into this case, here there is no resistor. It means the value of RF in this circuit is equal to 0. And if you see there is a absence of this R1, it means we can consider that the resistance of this R1 resistor is approximately infinity. So when this resistor is infinity, it means it is not connected to ground, it's very high resistance, so there is only, and the feedback resistor is 0, so it means the entire output voltage is fed back to a inverting case. So if this will happen, then what happens to the circuit analysis? So let's see that. So we know that the non-inverting amplifier equation, that is given by V0 is equal to 1 plus Rf by R1 into Vs. So here in this case, the closed loop gain can be defined as AF is equal to 1 plus Rf by R1. So Rf value is 0, R1 is infinity, so ultimately this is equal to 1. Then from this equation, so the output voltage V0 will be equal to Vs. This is very important to note here. Whatever the input we will give, the output voltage will be same as the input, in same phase, same frequency and same amplitude. There is no change in anything. Then what is the purpose of this circuit? So the purpose of this circuit is to, before applying the op-amp in any other circuit, we can test the circuit for its functionality. So by connecting in this fashion, we can check whether the op-amp is working fine or is it defective. So it's a very simple circuit and a special case of a non-inverting amplifier case. So that is why it is called as a voltage amplifier, because the voltage follows from the input to output with same phase and same magnitude. That is why it is called as voltage follower. Okay. So now we will discuss the another application of our op-amp. So that is a subtractor circuit. Now it has been 17 minutes. So I think if you start our subtractor circuit, it may take a quite long time. So I will discuss the subtractor circuit in the next tutorial. So here I will wind up. So thank you for watching this tutorial. Catch me in the next tutorial.